All right, everybody, we've just finished assignment 6E, and so we've got a ton of information that we've been working on and memorizing. Pythagorean identity, the unit circle that now has degrees on it as well, and the cosine tangent or reciprocal graphs. And then so the only new thing is the non-unit circles. So what I mean by that is you have to just write down SOHCAHTOA. That's what geometry taught us. The version that we're learning today in trigonometry is S equals Y over R. You don't have to do this bottom line, but really technically it's the Y coordinate divided by the radius, or the X coordinate divided by the radius. This is how the textbook writes it. I just remember it's SOHCAHTOA, and that helps me enough. So let's use that information in a big way today in assignment 6. And note 6.61, finding trigonometric function values, day 1. So some vocabulary. The instructions are to find the trig values for these values. So if the input is going to be 225, we want to find the trig function values. And so the hint that I'm going to use is draw the reference triangle. What's a reference triangle? It's a triangle with the x-axis and the terminal side. It's a right triangle. I shouldn't have drawn this kind of a triangle. It's actually a right triangle with axis and terminal side. So everywhere you see purple highlighted in these unit circles, that's going to be the reference triangle. So here's a reference triangle. You can see it has its axis. It's made with the x-axis and the terminal side of the angle. And then you got to draw like a vertical line. You always you insert another vertical line. Here you insert a vertical line to make this right triangle. What's the reference angle or number? So they might give you, say, negative 1050, and what you've got to do is somehow convert negative 1050 into the shortest angle to the x-axis. So the shortest angle of the x-axis goes from here, it's 30 degrees. It's the angle of the reference triangle. So here, they might give you some crazy number like negative 13 pi over 3, and you eventually draw the reference triangle, and it's going to be this angle right here that measures this radian distance of pi over 3 right here. You might go around in a negative direction several times and eventually land here, but the reference angle is going to be pi over 3. It's the shortest angle to the x-axis. All right, so let's actually do one of these examples. Example 1. Let's say they give you 225 degrees. What you've got to do is recognize that 225 is somewhere in between 180 and 270. You can, I would subtract out 180 to get 45 degrees. And you draw the unit circle. We know that we have to go 225 degrees, and then we can actually label that as 45. This is going to be a 45, 45, 90 triangle with negative coordinates because it's in the third quadrant. So here's the fraction version, here's the decimal version. And I think the fraction version is going to be easier. Let's do the fraction version just to practice working with fractions. It's not going to be easier. But anyway, the u coordinate on this UV plane here is negative square root of 2 over 2. And I'm going to continue the same color convention. Every time we see this particular one, it's orange, and this particular one, it's green, even though they're the same numbers. U is orange, V is green. So therefore, sine is going to be green, the V, and cosine is going to be orange. The tangent is going to be green divided by orange, which is just 1, the same number. And the cotangent is going to be I'm not even going to look at the previous ones. I know that the cotangent is the reciprocal of tangent. Secant is going to be the reciprocal of, it's like 1 over u. It's the reciprocal of u. It's going to be the reciprocal of cosine. Now, we can't just report that as an answer because we don't like radicals in the denominator. So you multiply that by a form of 1, square root of 2 over square root of 2. And then you get negative 2 square roots of 2 over 2. The 2's actually cancel, and you're left with negative square root of 2. That's the answer for secant. Cosecant is going to be the same for the same reason. Bam, those are all the trig values. Whew. Okay, let's go to example number 2, 660 degrees. Well, we have to wind around a couple of times. I I figured out that you have to go around 2 times because 60. I first subtract off a 360, and then I subtracted off 180. It actually doesn't go around 2 full times. That would be 720 degrees. You can subtract 360. You can subtract 180, and that gives you 1.5 times. And then I can even subtract 90 to get 30 degrees. So go around once for 360, go around once for 180, go around an additional quadrant for 90, and then it's 30 degrees past the 270 mark here, 30 degrees. So you go around all this 660, and then this is 30. To find the reference angle, that'd be 60 degrees. So we have to draw a 30, 60, 90 triangle. This reference angle is the shortest angle between the terminal side and the x-axis. Anyway, it's a 30, 60, 90 triangle. The short side over here is going to be 0.5. That's why we know that the location of this coordinate is 0.5 along this axis. It's actually exactly halfway between the origin and the unit circle right here. But then it's going to be negative square root of 3 over 2. The same thing as negative 0.87 or so. And so then you can find out that you've got u is equal to 1/2 and v is equal to negative square root of 3 over 2. That's the u coordinate and the v coordinate. Color coding it again with the same color convention. Sine is going to be equal to the green. That's the v value. Cosine is orange 1/2. Tangent is going to be green divided by orange. So there's some super fancy fraction work going on right here. But if you have a fraction divided by a fraction, that means you can multiply by the reciprocal. So we've got this green here. Maybe I could have even color coded this green, but now you've got the reciprocal of the orange, and so the 2's cancel out, and you're left with negative square root of 3. The cotangent is going to be the reciprocal of tangent, and I think it's easiest to take this result and take the reciprocal of it. So this would be the answer, except you've got a radical in the denominator, you've got to rationalize. So let's multiply both the numerator and denominator by the square root of 3. This times this is equal to 3, and so then you've got this, and it probably should be negative. This is a negative sign right here. Secant of 660 is the reciprocal of what we had. 1 over 2 becomes 2 over 1. It's just 2. Cosecant of 660 is the reciprocal of what we had here, green. And just flip it over. That would be the answer, except you can't leave a radical in the denominator, so multiply by square root of 3 over 3. And you get negative 2 square root of 3 over 3. Boom. Let's keep rolling. The reference, so if they give you 570, then I know I can subtract out 360 for one full rotation around, and then an additional 180 to get a half rotation, and then 30 degrees. So we're going to go once around, another halfway around, and then 30 degrees to get the reference angle right here, drawing this reference triangle. This is a 30, 60, 90 triangle, so then I know the short side is going to be 1/2, and the long side is going to be square root of 3 over 2 in the negative direction here along the u axis. So u is negative square root of 3 over 2, v is negative 1/2. You can take the sine of that. This should be green right here, negative 1/2, and the cosine is orange, negative square root of 3 over 2. Tangent, you divide the 2. Again, do that fun, happy trick where you can multiply by the reciprocal. So you get 1/2 times the reciprocal of the orange is now 2 over square root of 3. The negatives cancel out, so it's going to be a positive answer. And so then we get 1 over square root of 3, which would be the answer, except you got to rationalize. Square root of 3 times square root of 3 is 3, and then you get square root of 3 here. Cotangent of 570, it's the same thing. I'm just going to take the reciprocal, the easiest version that I found along the way. That was me cracking my knuckles, by the way. I hope I wasn't too loud on the microphone. We got this reciprocal of this is going to be this. You could take the reciprocal of your final answer and eventually rationalize it, but I think this is easier right here. Secant of 570, it's going to be the reciprocal of the orange. Is that? Rationalize it, you get that. Cosecant, it's going to be the reciprocal of the green. It just turns into negative 2. Now we remember, maybe I don't even have to tell you at this point, but we remember that these fractions are about 0.71 and about 0.87. All right, so negative 1050, oy vey. what are we going to do with this? I do know that the rotations of a triangle, like if you add 360, one rotation is 360, two rotations is 720, three rotations is 1080. I forget if I have that memorized or not. I think I had to multiply it out. But I think the easiest thing to do would be just full on add 3 rotations until you get to positive 30. There are a couple ways you could arrive at an answer of 30, but I think the easiest way is just to add 3 rotations. And you get positive 30. That's why this reference angle is 30. And the reference triangle you draw right here drops, you insert the vertical line, and now you've got a right triangle. This is a 30, 60, 90 triangle, short leg 1/2, long leg square root of 3/2. That's what U and V are going to be. Those are the coordinates, and it's orange and green. Playing that orange and green game, sine of negative 1050 is the green 1/2. Cosine is that. Tangent is going to be the sine divided by cosine, or V divided by U. Here we're going to have this. Take the reciprocal because we have fractions divided by fractions. You got to take the reciprocal of the denominator and multiply. The 2's cancel out. You're left with this, which would be the answer, except you got to rationalize and you get that. Boom. I'm actually going to take 1 over square root of 3 and take its reciprocal to find the cotangent. There it is. Secant, cosecant, very similar stories. I'm tired of talking. Been doing a lot of talking. You're probably tired of writing. Example 5, negative 13 pi over 3. Wow, that's just a really ugly number to think about. It's hard for that to make sense. But one thing we can do is add a full rotation. To get this negative number, I'm just going to add what is equivalent to 2 pi and 2 pi, but I need a common denominator. So negative 13 plus 6 is negative 1. And so I'm just going to go negative pi over 3 in the negative direction. From here to here is pi over 3. That's the same as 60 degrees. So we've got a 30, 60, 90 triangle. The short side is 1/2, the long side is the square root of 3/2, and we're going in the negative direction because you're going down. That's what U and V are going to be. Sine is going to be the same thing as V. Cosine is going to be the same thing as U. And tangent is going to be V over U. Take the reciprocal, the 2's cancel out, you're left with that. Take its reciprocal, and you've got to cancel it out. I want you to find the secant. And you can see I've got the cosecant there. Wow. This much talking and this much handwriting for you is probably death. And I say that because I was in Death Valley National Park